In this video, we're going to take a look at what is called the transformation of functions. We've already talked about the basic toolkit functions that we know, such as absolute value, x squared, x cubed, the reciprocal of x. And we know what those graphs look like, but graphs aren't usually centered at the origin like they are in our toolkit functions. So we're going to look at how we can take those standard graphs and shift them either left, right, up, or down. First, we'll look at a vertical shift. And actually, let's say we're going to do a vertical shift by k. If I've got a function like f of x, and I want to shift it by k vertically, to shift it vertically by k, what we're going to do is we just have to add that number k onto the end. And I'll put a little note that plus moves up and a minus moves it down. In other words, for example, I've got the function f of x equals x cubed. Now that's one of our toolkit functions, so we should be familiar with f of x equals x cubed. So let's just graph it really quick here. X cubed has a point centered at the origin at 1, 1, and at negative 1, 1, and it comes up. After going through one, it levels out, and then after going through the other, it goes back again. So that's x cubed. Now, if I wanted to shift that graph, maybe I want to shift it up 2 units. Well, now my function is going to be x cubed, and to go up, we'll put a plus 2 at the end. And that plus 2 at the end is going to say, okay, each of these points are going to come up 2 units. And so my new graph has key points here, here, and here. At negative 1, 1, 2, 0, and 1, 0. And now the graph is going to be up higher, shifted up vertically 2 units. So that's how vertical shifts work. Let's take a look then at horizontal shifts. By h. So the idea here is if I've got some function f of x and I want to shift it horizontally by h, what we'll do is we'll say f of x minus h. And that x minus h is replacing the x in the function. So wherever there was an x, you'll see the shift put into that spot of the variable. Now I'll put a note in here that if we want to shift left, you'll see a plus, and if you want to shift right, you'll see a minus. And that kind of feels backwards because we're used to positive numbers on graphs going to the right and negative numbers going to the left. And the reason for this is because the shift happens in the domain with the x. What actually is shifting is the background. The background might shift to the right 3, which gives the illusion that the graph has moved to the left 3. And so that illusion is what creates the opposite sign of what we might expect. So for an example, let's say we've got f of x equals the reciprocal function 1 over x. And we're familiar with the reciprocal function. It's one of our toolkit functions. Also has key points at negative 1, 1, 0, 0, and 1, 1. That middle key point is really an asymptote, so that doesn't really exist. But that's going to be the line. I'm going to draw it as a guideline. That's the guideline that the graph kind of gets close to. We call that an asymptote. And so that's the standard graph of 1 over x. Now, if I wanted to shift this graph to the right 2 units, then I replace the x with x minus 2, because minus is what shifts to the right. And that's going to take each of these points and shift them 2 units off to the right. And so now that center one becomes my guide or the asymptote line. And we see the curve of the graph going towards the asymptotes and through that point. And now that brown shifted to the right 2 units becomes my new function. Now these shifts do work on any type of graph, and we can combine them together. Let's look at both, where our function f of x is going to be shifted to become f of x minus h plus k. And the h tells me how far we're shifting horizontally, and the k shows us how much we're shifting vertically. So let's say, for example, let's make up a fake graph. Let's say the function f of x is graphed here. And let's put some fake points on here. Let's start at the point negative 2, 2. Let's do 1, 1. Let's connect those 2 points with a straight line. And then we'll do another point at 2, negative 1. And I'm going to connect that with a kind of a curved line going down. So that's f of x. And we want to shift it. Actually, let's just write down. We want to graph f of x plus 1 minus 3. Well, the plus 1 inside the function is a horizontal shift. Plus 1 will move to the left 1. The minus 3 at the end means we're going to go down 3 units. So each point is going to go left 1 and down 3 units to the new location. Okay, same thing with the other point. It's going to go left 1 and down 3 units. There's my next point, still connected with a straight line. Again, left 1, down 3 units, and it's going to be connected with the little curved line again. And there's my new graph that's been shifted left 1 and down 3, which we could see by the plus 1 in the domain and the minus 3 outside in the range. So that's how we can shift our graphs. The next thing I want to look at, though, is how can we make our graphs change direction? We can change directions on our graph with what are called reflections. So for example, if I've got f of x, and instead I put a big negative sign in front of the whole function, what this is going to do is give us a vertical reflection. Some people will say it means it goes across the x-axis. Oops, 2 S's. So for example, if I have the function f of x equals the absolute value of x, this is one of our toolkit functions that we're familiar with. We know it's got points at 0, 0, negative 1, negative 1, positive 1, and 1, 1, and it's going to make a perfect V. But now if I change the graph and put a negative in front of the whole function, a negative in front of the absolute value, that's going to reflect it across the x-axis. And so here's the x-axis, the horizontal axis. To get a vertical reflection, positive 1 becomes negative 1. The opposite of 0 is still 0, but now the graph is going to go down instead of up. Everything's just going to reflect across the x-axis because of that negative in front of everything. Now we could put the negative just in front of the x. If I've got the function f of x, and then I change it to just put a negative in front of the x, that's going to flip the domain. That's going to become a horizontal reflection. In other words, it's going to go across the y-axis. So, for example, if I take one of our toolkit functions, f of x equals the square root of x, square root of x has a key point at 0, 0, 1, 1, and 4, 2. So it's kind of this type of a shape. And if I were to instead put a negative in front of just the x, the square root of negative x, that's going to give us a horizontal reflection. And so this point at where x equals positive 1 is now going to be a negative 1. The positive 2 on x is now going, the positive 4 on x is now going to be a negative 4 on x. And what we end up with is a reflection across the y-axis. And so now that brown line becomes my new graph. And just like with the shifts, we could do both. Let's do this with a fake function again, just because those are a little more interesting. We're going to say this is my f of x graph. And we're going to do a point at -3, -2, a point at 0, 0, and a point at 2, -1. And we'll do a curve up on the left side and a straight line down on the right side. And we're going to graph negative f of negative x. Now the negative inside, that one's going to be a horizontal reflection. The negative outside is going to be a vertical reflection, which means my point's going to reflect both vertically and horizontally. So when y is -1, it becomes +1. X was +2, it's going to become -2. And so it's going to flip both directions. Flip across the x from -2 to +2. Then we flip from -3 to +3. Curves on that point, straight line on the next point, and now we've got our new graph. In fact, we can combine both reflections and shifts together into a single problem. We can see all these shifts together. Let's graph f of x equals negative absolute value of x plus 1 plus 2. Now first let's take apart what this tells us. The negative in front of everything, that's a vertical reflection. That vertical reflection is going to go across the x-axis. It's an absolute value. We know the absolute value graph from our toolkit functions is that v. We see the +1. Adding and subtracting we know is a shift. +1 inside the domain is a horizontal shift. +2 at the end, that's a vertical shift. So let's put that all together to make our graph. So let's see if we can graph this guy. All right, we know that the parent function for this is the shape of a V. This is our toolkit function. We've got points at 0, 0, 1, 1, and -1, -1. We know we're going to shift horizontally left 1 because of the plus, and up 2 because of the plus at the end. And we know that we have to flip it over the x-axis. So this first point on the left is going to flip over the x-axis. Then it's going to shift left 1. Then it's going to shift up 2. Its new point is right here at -2, 1. 0 flips onto 0 right onto 0. Then it's going to shift left 1 and up 2. Then I can take my next point. It's going to flip down to -1, left 1, up 2, and there's my new point. And now if I connect the dots, we can see my new graph is this shifted absolute value graph. So that's how we can transform our functions. We can move them left and right, up and down, and reflect them.